In our 28th lab program session, we will understand a program to find the factorial of a given number using recursion. In our previous lab programming sessions, we have discussed the same program, factorial of a given number using iterative method, and we will see the other way of finding the factorial using recursion. So here is the program to find the factorial using recursion. Here I have taken a function called factorial, and within this the parameters are n, and this is the function definition, and I have taken it as long int. Why we have taken long int? Because the factorial of a small number, a 15 factorial, is going to generate a very big number. In order to store that big numbers that are going to get as a written values, we need to declare them as long int. Now coming to the main part of the function, main part of your program. So in this program, I have declared two variables. One is the number for which the factorial has to be done. So that number, this is the variable name number, is used for that number. And the next is fact, means the written value of the factorial function. Whatever the value that is returned after finding the factorial will get stored in this fact variable within this main function. Now here we are asking the user to provide a positive number, and we are going to scan it into the number variable if the number is less than 0. So here we are addressing the edge case. The edge case is we cannot find the factorial of negative numbers, so that case will be addressed here. So we are going to print an error, enter positive number. So the error happened, and you have to enter positive numbers. Else, if the number is greater than or equal to 0, so then the factorial function will get called. So let's assume that the user has provided number 5, means we have to find the factorial of 5, and after that this printf will get executed. So let's see this function call. So how the factorial will get executed by using recursion, that we will try to understand here in this function call. Now the value of n will be assigned with 5 because the function call has been made with a value of 5. Now is the value of n is equal to 0? So this is our base condition. As we have clearly understood, first we have to identify the base condition, and the base condition is the value of n equal to 0? If the value of n is equal to 0, we have to return, means 0 factorial is 1. Okay, so what we have to do, we have to return 1. Okay, so this is the base condition, and if the value of n is not equal to 0, now we have to do this factorial. So this what we call it as recursive step. So what this recursive step is doing, so that we will try to understand. So let's see. Now what happens? So we have passed the value of n is equal to 0. Is it equal to, n is equal to 5. Is it equal to 0? No, it is not equal to 0. So what we are going to do is, so this part will get executed, recursive step will get executed. I am taking it as f. F means it is factorial. F of, this is not n minus 1. So we will take it as 4. Now this multiplication, so this multiplication is not yet done. Here the value of n is 5 and f of 4 has been called. Try to understand this. This is not completed. So this return value is not completed. So in this step, we made a recursive call. So what is this recursive call? Calling this function again with a value of 4. Now what is the value of n? New value of n, it is going to be 4. Okay, so now is it equal to 0? No, it is not equal to 0. So again this part will get executed. So this return function is not completed. So try to understand this. So now here the function call is, so the return value is, it is 4 into f of n minus 1. What is the value of n? 4. Now it will become 3. Okay, so again we have made a recursive function call here. F of 3 is a recursive function call, factorial of 3. So the new one is factorial of 3. The value of n is equal to 3. Is it equal to 0? No, it is not equal to 0. So it will become 3 into f of 2. And similarly, the next one, n is equal to 0. The new value of n is 2. So 2 into f of 1. Now again the function call will be made. Is the value of 1 equal to 0? No, it is not equal to 0. So here n is equal to 1 and f of 0. So here 1 minus 1, which is going to be 0. F of 0 will be called. Now this is the point that you need to understand. So now this function call will be made. So now what is the value of n now? Now the value of n is equal to 0. So here, so what is the return value? So is the value of n equal to 0? Yes, it is equal to 0. So this point that you need to understand. So from this point, it is very important for you to understand. So from here, watch this video as many times as possible until you get the clarity. Till here, it is normal and easy to understand. So this is how the steps will get executed in recursion. Okay, so now whenever the value of n is equal to 0, what it is going to return? So it is going to return 1. So now we got the first return value. So what is the definition that we have learned in our previous class in the recursion definition? It is a function calling itself, and we are going to call that function until the smallest possible solution for the problem has been identified. So this is the least possible solution that we have identified, which is if the value of n is equal to 0, we have to return a value of 1 because the 0 factorial is 1. So now the first return has been done. Now and this is where we are going to get a value of 1 and the multiplication will be done, and to whom this value will be returned. Try to understand this point. So the multiplication value is going to produce an outcome of 1. To whom this 1 will be returned? This 1 will be returned to the function which generated this part. So 1 into 1, who generated this part? This return part, it is 1 into 1 is generated by this function called f of 1. So we got this f of 1 into f of 0 by this function call, right? Now this is the calling function. So to this calling function, we have to return this value. Now the 1 will be returned for this function call f of 1. Now the multiplication is now done. Try to understand this. So 2 into 1 will be done, and to whom this value has to be returned? The calling function. So who generated this 2 into 1? The cause of this 2 into f of 1, it is generated by this f of 2. Now to this f of 2, this return value has to be generated. So the return value is 2. 3 into 2 is going to produce an outcome of 6. So who is the parent for this? It is f of 3. So the return value 6 will be returned back to f of 3. 4 into 6 is going to produce an outcome of 24, and it will be returned to this, and 5 into 24 is going to produce an outcome of 120. So this is how the things will get executed in recursion. And this example is very, very important for you to understand. So in data structures and algorithms, we will be understanding the same concept with respect to a process diagram. What happens on the memory? So that we will try to understand in detail in our data structures and algorithms class. So for this course, so this kind of visualization is sufficient. So that's it for this video. In the next class, we will be understanding the concepts of the difference between return and exit function in C programming language. That's it for this video. See you in the next class.